Hey everyone, my name is Ryan Kay. I'm a rising senior at Monte Vista High School, and for today I chose my project as the shoulder rehabilitation device with TinyML. Now I chose this product because I'm an open water swimmer, and I often face a lot of shoulder injuries and a lot of shoulder pain from the constant rotation from me swimming in the water. So I hope this device can help me mitigate these injuries and help me mitigate the pain from swimming. So how this device works is it displays on this OLED display right in the front here the shoulder rotations and shoulder input that I am giving it. So for example, I trained this based off of 3 different classes. So the 3 different types of shoulder rotations it's trained on is moving my shoulder to the right, moving my shoulder to the left, and finally letting it stay idle. So hopefully when I do my demo, that's exactly what it will produce on the OLED screen. So I will plug it into the battery and we'll have a look. It's going to take a while to focus, but as you can see right now, it says sampling. And sampling means it's a 2-second interval in which it gathers the data using the built-in accelerometer to measure the change in velocity to really determine which of the 3 inputs it should detect. As you can see right now, if I lay my hand by the side, it will be idle. So let me refresh that. Okay, as you can see now, it's sampling, and it says idle. Right, so that means it's detecting idle. If I move my hand, move my shoulder to the right for the next 2 seconds, it should detect right. And then if I move my shoulder to the left for the next 2 seconds, it should detect left. And so that is and now moving on to more about how this actually works. Before I even get a model, I obviously have to train it. So as you can see, this is an Arduino board. And in the Arduino board, there is a built-in accelerometer, like I said, which I use to gather the data in order to train my model. And now it detects the changes in velocity between each of my 3 classes, and that's how it can detect it. So after I gather all my data from the 20 minutes of data I've trained from the 3 inputs, I put it onto a software online called Edge Impulse. Now Edge Impulse is an online software that allows you to create your own machine learning models based off of your own data that you collect. So after I upload it to Edge Impulse, it is time to refine the model. Because after all these minutes of data, there is bound to be some excessive noise and noisy data that really does not fit into the model. It just causes more disruptance and less accuracy. So after hours of troubleshooting, of splitting the data, of cropping the data, making sure each data set only covers the amplitude of my rotations, then finally is the model accurate enough for actual testing. And after my model was complete and flashed onto my Arduino, I then went onto Fusion 360, also known as CAD, to create my 3D printed enclosure, which you can see on my arm right now, and it's strapped on my arm as well. So throughout my time at Bluestamp, I faced a variety of challenges since I didn't have any hardware or software experience when I first came in. But because of the wonderful instructors here at Bluestamp and the many resources they provided, I was not only able to finish the product, but also able to learn a lot of skills that were helpful along the way. And now a more specific challenge that I faced was the fact that my OLED screen did not display at the very beginning. As you can see, there's a tiny OLED screen strapped to the front. And at first I didn't know what to do because I didn't have a lot of experience. So I spent days just switching OLED displays, unsoldering and resoldering, not really getting to the root of the problem. And then after days of just confusion, I finally found the root of the problem, and it's very simple. I accidentally put one of the wires to the wrong input. It was a very simple mistake, and it took me too long to figure it out. That was one of the challenges I faced, and I eventually solved it. So if I were to redo this project, or even add on to this project, I would probably add a function in which it can detect the rotational degree of each movement. That way I can compare the degrees of rotation from an injured person to that of a non-injured person to really see how much of a difference this can detect. Now, I learned a lot at Bluestamp, a lot of hard skills such as how to solder, how to split data to make it more accurate, how to wire, read schematics, and build these prototypes and products. I also learned a lot of soft skills, such as how to persevere, to never let setbacks put you down, and also a lot more about the engineering process and about how failure and setback is always part of the process. It should never deter you from success. Thank you for listening, and I'm open for questions.